Hello, I'll start. My name is Sangchul Lee from Line Plus UIT Web Service Dev Team 4. I joined Line Plus in August of last year, and I have been working as a front-end engineer. My GitHub ID is 일상. I'm very interested in front-end open source. I would like to get to know many of you. Before I start, I'm going to ask a question that will run through this session. What does developer-friendly mean? I'm sure it has to do with many things, but I think it is strongly related to the improvement of developer experience. UI and UX are considered to be very important at the front end. A service being easy to use while providing a good user experience are key factors that directly contribute to revenue. In the same context, a developer who develops a library for service engineers must try to improve the experience of these engineers. Therefore, I'm going to share how to improve a library's user-friendliness by considering both DX and documentation in order to change a cumbersome task such as documentation into an efficient and meaningful task for the maintainers developing UI component libraries. Before we go into the main part of the session, let me quickly run through the agenda. First of all, I'll give you some needed background information for this session. Next, I'll share what problems there were in the existing UI libraries. And lastly, I will share how we solve these problems using TypeScript and Storybook. First of all, what is a UI component library? As the name suggests, UI component library refers to a library that holds various components which operate on the user interface and provides the component so that they can be used immediately without having to be created separately. This type of UI component library is implemented in a service through a download via NPM or Yarn. If we analyze the NPM packages used nowadays, there are approximately 1,750,000 packages and 30 billion downloads per week. This means that numerous developers depend on many libraries for their projects. And a large portion of these packages and downloads are of the UI component libraries that I mentioned earlier. And when I say that many developers depend on numerous libraries, that means that they have to look through as many documents. But what if there is little documentation for the library? This would increase the fatigue of the developers using the library. So most developers want a library that is intuitive and user-friendly. Of course, each library has its own system of documentation and document distribution to its users. And at the same time, the library developers feel that it is difficult to provide sample pages or documentations because there are not enough development resources or other reason. But above all, documenting is boring. When there is a change in the code, the related document also has to be revised, which makes the library maintainers feel like they are doing the same job twice. So to a maintainer, this task becomes unbearably boring, making it lose its meaning. Therefore, in this session, I'm going to share how we gradually solve these problems mentioned earlier based on the insights we drew while reorganizing the UVP, Line's Video Player Library. UVP is an abbreviation of Universal Video Player, and it is the video UI component library for Line News, Line Live, Line OA, and other various Line services. So with this backdrop, I'm now going to go into what issues existed in the UVP. Before the reorganization, there was difficulty with documenting in the earlier version of the UVP. The guidelines or the instruction manual for the developers were managed using README in the repository. So as you see here, example codes applied with UVP were provided separately as a sample project, and how to start and simple codes were given as examples. Also, documents for the API for the video player and FAQ were set up. However, the searcher would be led to a separate README page that has been set up separately. And because UVP used pure JavaScript and did not provide JS docs separately, it needed a detailed explanation in the API README document. This was a factor that made contributions by developers who use UVP difficult, and it made syncing between documentation and code and also the continuous maintenance of the library difficult. To show you some codes to explain the problem, in order to use a UI component library like UVP, the user needs to have an understanding of various options or methods provided by the library. The developer using the library therefore ultimately ends up reading the official document again. As the user reads the document, he or she gains an understanding of the combination of various options and methods to build components. In the code provided as example, the user needs to understand what options are available in UVP and how the option can be offered. And when the developer uses set resolution method, the user has to know what object array has to be provided in what argument. After understanding all of this, then the developer can start applying UVP to their project. The user has to go through all of this process to add a simple UI component, and during this process, the developer using UVP has to go to and from the README in the repository and code workspace repeatedly to write the code. Also, because the final result is provided as a screenshot, there existed a strong linkage between documents and images, which implies that it is difficult to provide rich examples. There is a limit in providing screenshot images to show what option will draw which component, which makes continuous maintenance difficult. And this was not a problem limited to maintainers. All developers using UVP for the first time have to go through certain steps to get the video player to appear on the screen. This means that the developer will have to go to and from the README page and code workspace. Is all this work really necessary just to use a UI component library? I thought about this question as I was developing the library. In order to check whether a UI component library is getting applied to our projects well, we go through a process of building a component using Webpack or Parcel for a project made via React, Vue, or something else while checking the Getting Started section provided by the UI component. If all developers have to go through this task to use the UI component library, a lot of time and traffic cost will be unnecessarily wasted. Now, I would like to go back to the first question I asked in this session. What does developer-friendly mean? I would like to focus on the inconvenience that existed in applying the UI component library. In my opinion, the three elements that contribute to developer friendliness are ease of use, kindness, and usefulness. Library has to be easy to use. The developer using the library has to feel that it is easy and light to use. A library also has to be friendly. It should save the time of developers by providing many use cases with good examples and documents. Last, it is its usefulness. It should be applicable in various environments. UVP's problems were with the first two, ease of use and kindness. The process of applying a component was difficult at the code level, and the provided document was not kind, so we worked on improving these elements. The most important goal to achieve through improvement was to transform UVP into a developer-friendly UI component library which can enhance DX. So the developers and the maintainers, who are our users, became the focus of our goal. In order to become an easy-to-use, friendly, and versatile library for the developers, we aim to make it easy to apply it in the workspace at the code level, and by providing many examples and options, we wanted to make it user-friendly and aim to improve DX in this way. Also, to avoid a situation where the maintainers would lose motivation from being overburdened with documentation, we wanted to make this task easy to do and meaningful. We also wanted to ensure that continuous documentation will get done, enhance the stability of the library, and increase its efficiency through automation. If good experience and user-friendly documentation could be provided through this improvement, we hope that user contribution could also become easier. We implemented TypeScript and Storybook so these core values could be satisfied. Now, based on the core values previously mentioned, I am now going to share how we reflected these values into UVP and what achievements were made in the process. The purpose of improvements between TypeScript and Storybook are slightly different. TypeScript syncs codes and documents using tsdoc and declare file and aims for IntelliSensing in IDE, meaning that it focuses on improving the usability for developers using the service by taking advantage of the benefits of TypeScript and optimization of IDE, the code workspace. On the other hand, Storybook is provided in a broader sense as a sample page. By using diverse add-ons of the Storybook, developer-friendly sample pages can be created easily. First, we'll take a look at TypeScript. UVP is written using pure JavaScript, and because it doesn't have JSDoc, there were several markdown documents that were scattered around. Therefore, this opportunity was used to port to TypeScript and implement tsdoc. By moving markdown documents into the codes, we wanted to encourage the users to easily apply the UVP at the code level rather than going to README in the repository. Also, by appropriately utilizing the declare file, we made it so that the separation and management of comments of types can be done easily. I won't use this time to go into a detailed explanation of what TypeScript is. Simply put, a TypeScript is, as you see here, enables the prediction of the values that will be received by using parameters or by adding type in the method, and it has a big advantage since issues that may arise in code can be found using IntelliSense before the runtime. Previously, there was no explanation about what values existed in the method that was used and what types had to be entered in UVP. So in order to correctly use the setAudience method, the user has to go back and look through the documents again. However, when TypeScript is applied here, type can be inferenced in the IDE. Just by enabling the application of the type in this way, there is definitely a great advantage in being able to notice what argument to use at the code level. And if tsdoc is added here, the effect multiplies. tsdoc is a tool that can maximize IDE's IntelliSense using only comment and simple syntax. Let's take a look at this image. Here, the keyword example is used and a markdown tag in JSX form is provided. If tsdoc is written in the method or the interface that is used like this, the developer using this interface can see the example on the interface displayed with highlights or is able to notice additional descriptions. UVP implements tsdoc and it can be used in this way, greatly enhancing the DX. What I will now do is use the many tsdoc keywords to make the IDE environment of the developers more colorful. Let's first take a look at the comments on the left. Here, descriptions of the arguments that will be received when video instances are generated are defined as parameters and separated. By doing so, a useful instruction can be given according to the location of the option that the user writes. Also, by using keyword C and link of the control methods inside a video class is provided. Let's try to see through the eyes of a developer using UVP by watching this video. You can see that every time the location of the argument changes, the description in the IDE also changes. Also, providing example code makes code writing clearer. Here, because the link to the internal method which plays an important role in the building of an instance is given, we can directly guide a developer who wants a deeper understanding of the flow of the internal works to the location where that specific code is. By introducing the process of exploring official documents in the IDE, we can reduce the frequency at which the developers have to leave the code workspace. I believe the implication here is great. Developers using this can stay on their workspace as much as possible so they can be more immersed in their work during development. This process is free of installing any dependencies and has the advantage that it will automatically be supported by IDEs like WebStorm and VS Code. If we use the keyword link mentioned in the video as well, we are able to provide a more precise instruction. In the case of UBP, the control method serves an important role when creating the video class. So if we write video controls as the link keyword to indicate the existence and location of relevant methods, we can send the developer from the IDE to the indicated location. With most libraries, compatibility always has to be taken into consideration. When a breaking point occurs in which specific method of parameter is no longer supported because of a big feature change, even if the change is well documented in the documentation for the library or a page, it is difficult to notify individual developers directly. For UVP, we notify the users through documentation or email to ensure backwards compatibility. However, this definitely is not a fun job for a maintainer. In this case, deprecated keywords can be used to provide a clear breaking point. Also, by providing keywords with link, we can clearly indicate to the users either migrating or versioning that this parameter or method is no longer available and add a short description of the reason why. We can also add an instruction for the user at the code level on how the user can use a similar feature. The user is able to quickly access and find out the necessary information while writing the code, which will greatly enhance DX. TSDoc provides a playground. Playground can be used to check how each keyword or feature is implemented and to see many examples. At this point in the session, two questions may come to your mind. First question might be, wouldn't it be difficult to write actual business logic if comments and codes are mixed together? Second, what can be done in the case when there are types or methods that you want to hide? This problem can be solved using the declare file. By indicating only the types or methods that will be displayed on the declare file, and by adding that to the TSDoc, only the types that have been marked to be displayed and their descriptions will be displayed to the engineers. Since this allows for a complete separation of business logic and TSDoc, also giving it a merit of separation of perspectives, it is beneficial to both the developers and maintainers. Types can be defined in declare file, and only the types that will be sent out from the types location of the package.json need to be defined. From the developer's perspective, this is beneficial because they don't have to see unnecessary types, and from the maintainer's perspective, the point of management reduces down to the types area because public type and DSDoc the maintainers have to manage are all gathered in one place. Therefore, instead of rewriting how to use a method as a document, the content added while writing the TypeScript is naturally incorporated into the document, freeing the maintainer from documenting everything twice. Next part is about the storybook. The TypeScript discussed earlier focused on improving the DX when the developers are writing codes. The DX is greatly enhanced just by doing this. However, there still is the problem that the library has to be installed in the workspace and applied with options. Also, there is a limit to providing guidelines for various examples. Especially with UI component libraries, it is common to provide examples of the results of components when they are applied with various options, so generally an example page is necessary. If such an example page has to be created manually, the cost of labor and maintenance should also be considered. This can be easily replaced using Storybook. Just to give you a brief explanation of what Storybook is, a storybook is a library that cuts out a specific UI component and helps the user check it right away on a web page. As you see here, Storybook has an advantage that its user can check the status of props that goes into a component, meaning that the user can check the status of each component by option. Therefore, from the maintainer's perspective, he or she can use the Storybook when developing the UI component library to remove the processes that come before a component is drawn. For example, a component whose UI form changes after it pops up. To test this, the process of making that component pop up is needed as a pre-process. However, if the maintainer utilizes Storybook, he or she can skip over that pre-process and can see the look of the component when it pops up right away. Another attractive characteristic of Storybook is that it has a big open source ecosystem and diverse add-ons. We can use these and the functions provided by Storybook to make sample pages more easily. Therefore, for UVP, we adopted Storybook to improve the productivity of the maintainers and also for it to function as an example page. First, I will reproduce the problems of the UBP document that I mentioned earlier. In order to check what methods or options exist in UVP, the user has to look in the document, and if the corresponding feature changes, the document has to be revised. Also, the screenshots showing the results of what happens when options are applied had to be updated. The documents basically have to provide the API information, how to use, and related options for a component. On top of that, the resulting look of the component also has to be provided. A total of 3 elements are needed. This was improved using the Storybook. Let's check the look of the page with the Storybook applied right away. First, here is the final appearance with the video component applied. At this time, we use the code sandbox to understand the component changes due to code modifications right away. You can see that code modification is reflected in the component immediately. Also, by providing a preview of what options and methods are available, the changes of UI components according to the options are shown intuitively. Additionally, the document and the corresponding example are mapped one-to-one. The description of each component is written in Markdown document, and now that component can be cut out and tested. By doing this, documentation and example pages are linked together. The point here is that the Storybook that is required in the development process of the maintainer becomes the document for the developer using the library. Now, let's take a look at a few things one by one. The maintainers of the UBP wanted to avoid the work of creating a separate sample page. We tried to think of a way to naturally integrate the development process and sample pages and chose Storybook as a result. If we use the basic essential features in Storybook, example pages can be easily built, and component development can also be done inside of the Storybook. We first create stories directory, then create a file including the stories. Then, if we bind the template in charge of returning the component that will be displayed, document that looks like the one on the right is generated. That is all that is required to create a page. Because the option of corresponding component can be seen right away using controls, it is convenient for the maintainer when it comes to development, and the developers using the library can omit the process of downloading a package and building to check the appearance after an option is applied. At this point, if we utilize the MBX file in Storybook, we can further improve the versatility of documentation. MDX allows the user to embed a JSX component in the existing Markdown syntax. Because JSX syntax can be used as is, the benefit is that component used in the code can be imported and applied. As you see here, import, export, and JSX syntax are freely used in the Markdown file, and the data is passed to the JS file component. As a result of that, as you see on the right, Markdown is drawn dynamically according to the data that has been passed on. If we use MDX, many versatile libraries of NPM can be directly used in Markdown. So by using chart, SVG, table, and other component libraries, the possibility of documentation can expand indefinitely. In UVP, story was written for each UI component, and the story was matched one-to-one to a MDX, so that document and result of build of each component could be reflected in the MDX as one. We also added the code sandbox to UVP, taking advantage of the flexibility of MDX. Many options existed in UVP, and the method of application for each option was slightly different. Therefore, we implemented Code Sandbox to help with the pre-test of the developers using UVP. If we use Code Sandbox, various examples and environments can be provided through the sandbox, and the actual build result is displayed right away. Because application in various environments, including React, Vue, and Vanilla, can be provided via Sandbox, confusions regarding options decrease, and the hurdles for usage is lowered. If we use the add-on of MDX Embed, we can easily provide a real code environment such as Code Sandbox or CodePen to Storybook's MDX files. How to use it is very simple. As you see at the bottom, the user would input the Code Sandbox component, then provide the workspace ID generated by the Sandbox IO, and that's it. By doing so, the developer wishing to use the library can check and apply the feature they want right away on the website without having to install and build their private workspace. Beside this, if we use the many add-ons offered by Storybook, we can provide richer examples and more convenience in the development stage. I want to talk about two things. First is the Viewport Add-on provided as a default. If you are applying responsive design, you can easily provide a viewport example through Storybook. Second is the StoryShot add-on. This is a useful add-on for the maintainer. StoryShot allows an easy application of Jest Snapshot feature to the Storybook. Maintainers refer to the Storybook during development. In the case there is a change in the internal logic, the maintainer checks the Storybook to see if the UI component is being drawn normally. This process can be automated and verified during the PR stage with the use of the Storybook. Now, I'm going to deploy the completed Storybook. Storybook can simplify the versioning of documentation through static builds. As you see here, static output can be extracted through the build script provided as a default in the Storybook. By attaching the version as the prefix to the output, then making the deployment URL can be separated by versions. When the output is uploaded to the CDN, the site will appear right away. So servers do not have to be taken into consideration. Issue of maintaining example pages decreases. There is a lot of interest in versioning when it comes to libraries. UI or methods could be added or deleted in different versions, so documenting changes and versioning are necessary. Through the static build of the Storybook, it is possible to significantly reduce the work for versioning and for example websites. This is how example pages for maintainers and developers can now be easily created for UVP. We provided a way for a continuous documentation and a stable library development environment for the maintainers and easy application and friendly example pages that can be easily created for the developers using UVP. like this. Using TypeScript and Storybook in the development stage can result in additional benefits. That's the end of my presentation. Thank you for listening.